Okay. Uh, Heat is energy, all right, and we measure the energy of something by its temperature. That's how we measure its internal energy of things. So we're going to be talking about two kinds of energy. We're going to be in this class. We're going to be talking about the internal energy of the body, which is the calories it's burning and the heat that it's giving off and things like that. Which in this case is heat production, heat exhaustion. When you're exercising, your heat production increases, and if heat isn't removed quickly enough, like through the body's natural defenses of sweating, slowing down, stopping, going to a cool place and rest, sipping some cool water, potentially hot enough, you can die. And as a matter of fact, this high school coach was charged in a player's death. This was a while ago. I don't know what exactly um, happened, but this what the outcome of this case was. But anyway, a 15-year-old boy died, and it's a very serious thing. Uh, there's kind of this a friend of mine was well, still is, I think. He's actually a football coach up in Alaska, up where in Valdez at Valdez High School in Alaska. Now they started their football season um, about a month ago or so, because once the clouds start rolling in over the mountains, that means winter's coming, and there's no way you can play football. And, they have snow on their games in August, and the kids fly in little commuter planes from game to game, from town to town to play. Um, but they don't have a heat exhaustion problem. They got a frostbite problem, towards the end of the season there with their games. But still, you can still get too hot even in cold weather. You can overheat, but it's a real problem because football's very popular in the South, and practice for football season starts now or last month, and it's incredibly hot and it's very, very dangerous. Now they have helmets with monitors on it, so when a helmet gets to like 103 degrees, which is serious, if a person's skin temperature, if they're running a fever of 103, the body will start to shut down. Sensors go off, and coaches tell the player to stop and rest. I remember when I was in high school football back in the 70s, it was the macho thing that you didn't get water till the end of practice. I mean, it's just stupid. It's a wonder that we just weren't all killed. George Patton, when he was training his armies out in the Mojave Desert before they went over to the desert to fight Rommel in the Great Desert Campaign at the early parts of World War One, they did the two worst things you can do. They didn't take water while they were there because they were making themselves tough, and they thought that salt worked. Salt does work, but not in the way they thought. And so when they'd give you salt tablets, they were killing you. Basically, it's amazing how we've changed. But anyway, so that's the thing on heat exhaustion. All right, elite marathoners limited by their heat dissipation. In other words, they can't run any faster because they can't get rid of the heat enough. Otherwise, they will drop, and you'll see it in the dehydration video. Some marathoners and ultra marathoners. Okay, now the way to avoid heat exhaustion: produce less heat, remove heat quickly. This is kind of a cool device because what you do is you grab it, and so your hot blood that's coming in gets cooled, and the cooler blood, and it's only a difference of a temperature, a degree or two, goes back and starts cooling down your system. That's kind of a neat thing. All right. And then this is our last slide. You can actually, if you go to set up a slideshow and click on this, you'll go to the last slide, which is this Todd Clever, this stud rugby guy. All right. He's amazing. All right. But anyway, there's a lot of good information on heat exhaustion. And then we will move from internal work of heat to and energy to external energy, what we call mechanical work, which is good old force times distance. So you understand what a force is. It's a change in velocity over change in time. And that's an acceleration. You take a mass times that acceleration, you get a force. Now we're going to look at force times distance equal work in mini lesson 4. All right, but this is the end of mini lesson 3. Enjoy, and I'll have a new lesson for you either tomorrow or Thursday. Okay, out here.